Okay, this is the last section, which is transformers. Okay, very quick, and we don't really see too much of this in algebra based. Okay, just because it is. You don't really see too much of this in algebra based, just because it is a little bit more advanced and a little bit and a lot easier to explain with calculus. Okay, but what we do see, okay, is that we have, this is what a transformer is. Okay, you put a battery on one end attached, so there's a coil around one, it's attached to a battery. The other coil doesn't have a battery attached to it, but you can actually induce current into it. Now there's something important to note here, is that this is actually, the ammeter is actually flipped from what it should be, so our results are going to look a little bit different. Okay, now what's happening, right, is when the primary current is positive, okay, um, then it circles to the left. Okay, when it decreases, okay, the current in the secondary coil, okay, is directed to the, in secondary coil is directed to the left. Okay, because induced current opposes the change. Okay, now let me draw what this graph should look like and then explain why it looks like that. So what it should actually look like is it's going to be, should look like this. Okay, and it should be right, that's like a negative sine graph, right? Okay, and so you have this negative sine graph here. Okay, and the reason why we actually get this, the explanation, and the best explanation I can offer for you, that is unfortunately calculus based, is that this up here, if you take the negative derivative of the current in the primary coil, it gives you the current in the secondary coil. Now, why is it flipped? Okay, why is it flipped? Because this is not what it should be, right? If you know your derivatives, you know that this is not what it should be. The reason it's flipped is because the ammeter's direction is flipped, right? So the ammeter, if the positive node was on the bottom and the negative was, then this would be actually work out just fine, okay? But you can notice that. A little bit of an algebra-based explanation for it, it's not a very good explanation, is this, right? You notice that this is a decreasing left current, okay, and then here this second segment is an increasing right. Okay, this first segment down here is going to then be increasing left. Okay, and then this segment right here would be a decreasing left. Okay. Okay, so that's just kind of giving some context to it. Again, like I said, the thing that's probably best to think of it is in terms of derivatives, right? It would be negative derivative of the primary coil's current gives you the secondary coil. Again, this is mostly just because our ammeter is flipped. Okay, then from what it should be. The point of a transformer, though, is pretty straightforward. All it is it literally exists to take high voltage, low current electricity in one circuit, okay, and transform it into low voltage, high current electricity in another. Why might we need that? Because maybe having high voltage electricity is not necessary for one circuit. Maybe a circuit can't handle it, right? So we need transformers to kind of be able to swap those around to be able to make things work better. Okay, that's it for transformers. It's super short, and that's it for unit 3 of Physics C too. By the way, all right. So have fun, do well. Yeah, bye.